Hello all, welcome to the show. I'm Gus Gagliardi and this is Fire Code Tech. On Fire Code Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Fire Code Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Hello all. Welcome to episode 54 of Fire Code Tech. On this episode, we're speaking with Bill Denney. Bill is talking with us today about aerosol fire suppression. It's a pretty unique episode in that Bill was listening to a solo cast about alternative fire suppression that I did weeks back and reached out to talk about aerosol fire suppression since I mentioned that I didn't have much knowledge about the subject. We get into design considerations, layout, physical and chemical properties of aerosol fire suppression systems, and much more. Also, we break down what are good occupancy and use fits for this technology. Really enjoyed speaking with Bill. He is so knowledgeable about aerosol fire suppression and has a deep understanding of fire science and all of the component factors of this suppression technology. Don't forget to subscribe so you never miss an episode and give us a follow on social media. Oh, and if you do me a huge favor and give a 5-star on Apple Podcasts, that'd be a big help. Let's break into the show. Well, Bill, thank you so much for coming on the podcast. Welcome to Fire Code Tech.
Gus, I'm delighted to be here. Thank you for having me, and I really look forward to our discussion today. I enjoy your podcast very much, and
Awesome.
to think that I can be here, just great. Couldn't be better.
That's very touching. Yeah, I really appreciate. We were talking a little bit off air about how you discovered the podcast and how you've been listening for a while. But yeah, I'm excited too to speak with you about your career and the knowledge you have about aerosolized fire suppression. But as you all know, I like to get these things started with giving people a little bit of background on your career history and, kind of how you found fire and life safety. Yeah, would you mind telling me about that?
Yeah, sure, be happy to. Like many of your guests that you have on the podcast, I did not set out to have a career in the fire and life safety business. It all came about quite randomly. The mid 90s, I was looking for work. I had left my job installing car stereos. Your guest, you had Joseph Cervantes on, and a few of the things he said kind of resonated with me. He was installing car stereos at one point. That's what I was doing at the time. But I left that and I was looking for work and I couldn't seem to find anything. But every time I looked in the paper, I always saw an ad for a company that was looking for alarm technicians for burglar alarm systems and CCTV and stuff like that. And I had, an electronics background from high school and some correspondence classes I had taken. And so I thought, well, something's better than nothing. I'll apply. And if I get it, I'll keep looking, to find something better. And I'll just do that until I can find something that I like. But funny thing, I really found that I enjoyed the work. We were, installing all types of alarm systems, security, fire, CCTV, access control, intercom, everything low voltage. And it was nice because you get to move around. You're not at the same place every day, and you get to use your brain a little bit. You get to a place and the panel is in trouble. It has a ground fault or something. You got to kind of think, well, what's going on here? What could be the problem? How am I going to fix this? And when you do fix it, you use your tools and your brain and you figure it out. You leave. I liked that. I felt like I could go away with a sense of accomplishment that I did something. But after a couple of years of that, I kind of realized I probably couldn't make a lifelong career out of being in a truck, moving around, climbing up and down the ladder every day and everything like that. And the company we work for, we were a big radionics distributor. We sold radionics security systems and a lot of them. And I learned that radionics was looking for technical support people. And so I went to my boss and I told him, hey, radionics is looking for tech support people. I want to try to apply. Radionics was in California. My parents lived in California, and it just seemed like a good move. I could get into an office environment and a company where I might be able to progress. Whereas with the alarm installation and service, it kind of, it is what it is, and there was really no path forward. And he said, yeah, sure, no problem. I'll give you a reference and everything. But he said, but they're not going to hire you. And I said, well, why? He said, they're looking for people that have a lot more experience in the industry than you. I had only been doing this work for about 2 years. But he said, go ahead and try. And I applied, and they did hire me. And I think he was always kind of pleased with the idea that one of his guys got hired by a manufacturer. And so I worked there in the tech support department for a few years, and Radionics was bought by another company, and they closed the office in California and moved everyone to New York. At that time, I didn't want to make that move. And at Radionics, we used Hochiki smoke detectors and products. And Hochiki was starting to come in with their own fire alarm panel around that time. So this was around 2003. I went to work at Hochiki for tech support and training. And I've kind of been there pretty much ever since, really.
That's awesome. Very cool to hear about how you had a similar through line in your incipient stage of your career as Joseph Cervantes, having that proclivity for electronics and really searching for something in the job market and those things kind of clicking together. That's cool to hear that come together like that.
Yeah, that was another thing that Joseph said when he started out. He realized if he was going to get ahead, he had to really read a lot and study. He read the code books and everything. And I was the same way. I devoured whatever information I could get. And my boss saw that, and he bought Nfpa 72 for me and 70, and that was a little over my head at the time. But I kind of realized if I'm going to be able to continue and progress and grow professionally, I'm going to have to learn. I'm going to have to do more than just go on service calls every day. And that was something that Joseph emphasized as well. And I think it's a good point probably for everyone. We need to have some way to grow professionally and learn and expose ourselves, to other parts of the business and the industry. And that's one of the things I've really appreciated about your podcast. I get to hear experiences and ideas and things from people that are doing different aspects than what I might be doing every day.
Yeah, that's awesome. I'm really inspired myself by people's stories, and it's always been one of the things that has given me a lot of meaning, and just hearing about how people have taken the challenges that life has to offer and overcome. That's like helps provide some, even if short-lived, motivation and inspiration to really try to lean into your own life or bettering yourself. So I feel the same way, Bill,
Yeah.
about just professional development and personal growth. But yeah, so I'm excited to hear about how you started and then your transition to a manufacturer and then your movement to Hochiki. Yeah, would you go over a little bit in more detail some of the roles that you've held at Hochiki since you started and kind of what those have looked like along the way?
Oh, sure. Starting out in the field, obviously, I was just an installer, pulling wire and, mounting devices and doing service calls with all kinds of different things. When I went to radionics, of course, I did technical support there. That was kind of a transition that I didn't expect. When you're in the field and you go to a site and you've got a panel and it's got a problem, you can, use your eyes and your hands and your tools, and you can kind of check it out and see it and work it out. But when you're on the phone now in a tech support role and you're talking to someone who is there and they see it, it's different. It was a transition for me. It took me probably about 6 months or so to really get my head around that, because now you have to ask them to be your eyes and ears and hands to identify what the problem is and how to fix it. And not everyone is at the same skill level. Some of the guys that would call, that they were just kind of thrown into it, and they didn't, maybe have the training or the background, and they needed help. And sometimes that help might include explaining to them how to use the meter, to measure DC voltage, or how to, do other things that are necessary to be successful as a technician. And sometimes, they might think that you're just going to tell them some quick answer that's going to solve all the problems in the whole world. And it doesn't always work like that. And you might say, well, did you check the voltage on the zone? And they say, yeah, I checked it. You say, okay, well, how much was it? And they tell you some number that is completely impossible. And you think, okay, they didn't check it. And now the challenge now is, how do I ask them to check it, or have them, do what I need for them to do without insulting them or offending them in some way? How do I help them to see that I'm on their side, and we've got to be a team and work together here? And it took a little time to kind of get my head around that. But once I did, that was nice and it was enjoyable. Moving over to Hochiki, I started with the tech support. At Radionics, we'd get a lot of calls every day. At Hochiki, when I started, we would get 4 or 5 calls a day. It was me and another fellow who were doing the work. And but I did the tech support there. I helped with that, and I developed the training program for the panel that we released at that time, an analog addressable panel. And from there, I've done some writing of technical manuals, documents. I've worked in the research and development department. I've done some firmware validation testing. I do design and application support for our customers now. Whatever comes my way. And that's one of the nice things about being here, is I do get a lot of variety. It's every day is something different, and that always keeps it interesting and an opportunity, possibly to learn something along the way as well.
Yeah, that's awesome. It's always rewarding to have, I've spoken with people about, where they had jobs. I spoke with one individual early on in my career who had a CAD tech job where he laid out cabinetry for a big box, manufacturer company, and he'd said that the monotony of just laying out these same CAD details over and over again was just mind numbing. And so I have never had to deal with that. Being in fire and life safety has been, I've rarely, if ever, even buildings where people say they're identical, they're usually not.
Yeah, exactly.
Yeah, identical. And it's very hard to present identical with, everything and siding. So I agree with you. But this podcast started because you reached out and were talking to me about how, aerosol fire suppression. And I had made some comment in one of my solocast episodes. I was talking about alternative fire suppression. I think it was section 904. I was talking about in an episode in a solocast, and you reached out because you have a specialty in that subject. But what is am I even using the right terms? Aerosol fire suppression, or aerosolized fire suppression. How would you term that?
Usually they would call it aerosol, or maybe condensed aerosol fire suppression. That was Solocast 27. Yes, I was walking and listening that day, and you were going through the list of alternative fire extinguishing systems in section 904 of the IBC. And you were going through them: wet chemical, dry chemical, foam, CO2, clean agent, and so on. And I was wondering if aerosol would come out, and it did. And I laughed and I said, I've got to reach out to Gus and offer to send him some information about the technology. And you're right, it's not something that everyone knows about. It's been around a long time outside of the United States, but the Nfpa and UL standards that are applicable to it haven't been around a long time. But aerosol, fire suppression, or condensed aerosol, basically an aerosol, right, is a suspension of very tiny particles in a gas. It could be fog is an aerosol, smoke is an aerosol. Condensed aerosol fire suppression works by using very, very tiny particles of potassium suspended in the air. And so it's really kind of clever how they do this. The aerosol itself, before it is discharged, is contained in a solid compound, okay? It looks a little bit like, to me, it looks a little bit like maybe a chunk of particle board or something like that. And the aerosol is stored inside of these steel containers. They might be cylindrical, or they might be a kind of like a box, and they have holes on one side so that the aerosol can get out. And these boxes or these cylinders are called aerosol generators. That is the term that is used in Nfpa 2010. They don't really generate the aerosol necessarily, but they do contain that solid compound. And these aerosol generators or containers are installed inside the hazard area. They're not pressurized. They just have this solid compound in it and a few other little components there. So they're installed in the hazard area, maybe on the ceiling or high up on the walls somewhere. And they're activated usually electrically from a listed releasing control panel. So it would be like a clean agent system in that respect. You've got a cross zone of smokes or smokes and heats. The panel goes into alarm. Both of the zones are in alarm. The panel starts counting down a pre-discharge time to allow people to get out of the room. And at the end of that time, the panel will send an electric voltage, usually 24 volts, to these generators. And that voltage creates a condition where that solid compound is converted from a solid mass of aerosol forming compound to an aerosol that's based on very, very tiny particles of potassium carbonate. There's also some nitrogen generated and some water vapor and things like that. But it's primarily the potassium, and the particles are very small. They're according to the definition there in NFPA 2010, they're generally less than 10 microns in size. Now, to get an idea of 10 microns is the average diameter of a human blood cell, red blood cell. So the particles are extremely small. And the generators will just, fill the room with these tiny particles of potassium carbonate. Now, the potassium extinguishes the fire by interfering with the chemical chain reaction of the fire. The potassium is it's one of the alkali metals, and it only has one electron in its outer shell, so it's able to disassociate and become a potassium ion. And that's what happens. The potassium moves into the flame. The heat of the flame creates a potassium ion that has a positive charge. That positively charged potassium ion bonds with the free radicals from the fire and breaks that chemical chain reaction that is going on. And that's how it extinguishes. It doesn't displace oxygen. It doesn't work, primarily by cooling the fire or things like that, but it works on that chemical level. And because it works at the chemical chain reaction level, the extinguishing action is very fast. during our training classes that we have on this product, we have one of the test results from the UL testing. And in the UL testing, they have a small space, where they light test fires and check to see how well the aerosol works. And for the test results that I have, it shows that all 5 of the test fires were extinguished in about 2.5 seconds. So the extinguishing action is very effective and it's very fast. And primarily, that's because of the way it works, focusing right in on the heart of that chain reaction. I hope that makes sense.
No, yeah, that's great. I love the visuals. That 10 microns is an interesting number because that's also like around some of the thresholds for combustible dust. So I appreciate you using some, information to really drive home the point, and you have a really solid understanding of not only the technology but the fire science behind why this technology works to extinguish the fire. Um, yeah, I really appreciate that.
Yeah, when I started doing the training, which also was sort of another unintended thing, I was asked to develop a training program for this technology, this product at Hochiki. I didn't know anything about it, but I told them, sure, I'll make a presentation. I figured I would read the manual, and I did. I read the manual, and I saw that it breaks chemical chain reaction fire, and I thought, okay, well that's great. But then I started thinking, somebody's going to ask me, well, how does it do that? And so I thought I need to investigate to see how fire works. How does fire burn? What happens during a fire? And wow, that was quite an investigation. I guess I still don't have a grasp on that yet. As I started studying, I found out the fire is a very complicated thing. Um, but yeah, that was part of it, and all of that. I guess I was anticipating questions that never really came. No one ever asked me about that. It's funny. I've been doing this training now for probably 7 years, 8 years. I don't think anyone has ever asked me, but I had to know for myself. How does it interfere? What does that mean exactly? And so, yeah, I did a lot of reading on that, and it is quite interesting. I'm sure you had to learn a lot about combustion and things of that sort in getting your degree.
Yeah, it's funny you say that because I can't tell you how many times I've looked at the fire tetrahedron now, and or just understood that when they talk about inhibiting the chemical chain reaction and how that can stop the course of a fire. But I've never really, and I have taken quite a few chemistry courses, and because originally uh, I was going for a different degree in
Mhm.
chemical engineering before I transitioned to fire protection. And so I made it all the way through like organic chemistry too. But yeah, I never ever had the thought to really investigate the actual mechanism at the atomic level for
Yeah.
how these particles inhibit that reaction. So to me, that's extremely interesting. Like,
Yeah.
but
Go
yeah,
ahead.
no, I
Go
just
ahead,
go. I
please.
was just gonna go on like one of the like another reason why your vivid description of the um, chemical chain reaction and like the 10 microns being associated with the blood cell. Like my first one of my big moments in my life I ever realized I had any interest in science was my chemistry teacher in high school telling me that a mole, so like Avogadro's constant for how many particles are in like the standard mass that we use to count for elements, like
R-
6.02 times 10 to the 23rd. Like to get a visual representation of that number, like a mole of peas would cover the entire earth with 3 feet of peas. And so that was how he described like the sheer size of this number, what 10
Yeah.
times to the 23rd really looked like. So
Yeah.
that really was like a big aha moment for me.
Those kind of things help us, I think, but still the idea and the concept of it is, I find it to be very challenging. You know, that many peas all around the earth. Sure, it's a lot, but trying to, visually picture that is I find that to be still a bit of a struggle. It's interesting. Well, we'll come back to that later, the aerosol particles, but they are very small. And in fact, 10 microns is the size of the largest particles. Most of them are
Wow.
actually smaller than that.
Very cool. Very cool. So is this like similar compounds in like technology as fire extinguishers? Are these the same kind of bicarbonate and potassium compounds that are in extinguishers? Is this like similar technology?
It's different. It really is different. The particle sizes are much smaller. That's kind of what I was
Mm,
going to say just a moment ago. It's not a clean agent, right? Because it is based
hmm.
on these very, very tiny particles of potassium. So there is going to be a little bit of residue, like a dust, like a very fine dust after a discharge. Not like a dry chem system, not like a handheld extinguisher, much, much lighter than that. And I used to get questions in the beginning. I was doing product trainings, and people were very, interested in that. Obviously, I think they were picturing dry chemical systems, and I would try to tell them it's not like that. It's more like a kind of a light dust. So I was very clever. I thought I was clever, and we were doing a discharge one day at the Hochiki office, and I thought, here's what I'm going to do. Great idea. I'm going to get a broom, and I'm going to try to sweep up some of the residue and put it in a little vial, and I can take it around
Hmm.
with me and show it to people, when I do the
Mm,
training. This is what it looks like.
hmm.
But the particles are so small. This is one of the things about the aerosol. The particles are so small and buoyant that they want to float. They tend to stay suspended in the room or in the air. If there's a ceiling, they'll stay suspended for maybe an hour, 15 minutes or so before they finally all
Wow.
settle out. We were doing this outside in a little area that we had kind of covered with plastic. And as a result, when we opened it for me to try to collect my aerosol specimen, it all floated away
Wow.
into the air, and I didn't get anything.
Wow.
So I thought it was a great idea, but in reality, didn't work out the way I intended it. But that is one difference. I know we're going to talk about differences. And that's why it has a different NFPA standard too, 2010. It's not a 2001 clean agent. It does use particles. That's what makes it an aerosol. But the particle size and the residue that's left is very, very fine, very light.
Wow, that's incredible. I never would have guessed that. That really brings to mind the physical, and now you talked about the physical characteristics and the chemical characteristics, but it really is unlike clean agent or like, a dry chemical fire extinguishing system.
Mhm.
That's pretty remarkable, really. I wouldn't have guessed that.
Yeah, it's kind of in a class of its own. It has its own UL standard. It has its own NFPA standard. So it is unique technology in that regard.
Cool. So let's talk about the codes and standard structure around aerosol fire suppression. Would you speak a little bit about that NFPA standard in which you would base the design for these systems on?
Yes, absolutely. That's NFPA 2010. That's the standard for fixed aerosol fire extinguishing systems. And of course, at nfpa.org, as you have mentioned before, and I remind people quite regularly, you can sign up and you can see all of the NFPA standards there at no cost. And so NFPA 2010 is the one. It's in its third official revision. We're on the 2020 edition right now. It's not a big standard. I would guess the body of the standard is maybe 20 pages, something like that. It's not like the NEC or 101 or anything like that. But the information is there. The definitions, of course, in chapter 3, general information, and then the information about how to design a system, things that we need to be aware of as we design the system as well. And then some information in the annexes also. The UL standard for testing is UL 2775, which is the standard for fixed condensed aerosol extinguishing systems. There are other standards. As I had mentioned, this technology's been around a long time outside of the United States. There are European standards, the ISO 15779 is their condensed aerosol systems standard. There are some other approvals, marine approvals. There's a Russian standard, NPB 2198, that they have for this technology. Another thing that kind of comes into play too is the EPA, the Environmental Protection Association. The EPA has the SNAP list. You know about the SNAP list. There they developed that list in an effort to identify substitutes for ozone depleting chemicals like halon. Um, and so the EPA SNAP list also has a place for condensed aerosols so that they can be evaluated and included on the SNAP list. And EPA, the SNAP list will look at the aerosol from two aspects, I guess. Well, maybe three. The first would be, is it included on the list at all? Another would be, can it be used for normally occupied spaces? Or is it only for normally unoccupied spaces? And so the SNAP list, the EPA would also apply. Here in the US, Nfpa 2010, UL 2775 for the manufacturers primarily, and then the EPA SNAP list.
So I don't know too much about the SNAP list, although I understand the concept of
Mm-hmm.
these substances that the EPA is saying, let's move away from these substances. I know that most recently we've seen the industry start to deprecate and move away from like FM200.
Mm-hmm.
So some of these HFC having clean agent systems, and then obviously halon in the past
Right.
being a huge one that they've moved away from. But that's interesting to hear you speak about that part of the
Yeah.
industry.
Yeah. Halon was very effective, but the Montreal Protocol, obviously, they were concerned about identifying the ozone depleting substances. And so that was addressed. And as you pointed out, I understand that some countries are now sort of phasing down HFCs too. I had understood that really applied more to HFCs used in refrigeration, but it may be touching fire suppression, or perhaps at some time in the future it will, and so yeah, those are, I guess, considerations for those types of products.
I could be wrong about this. People should double check me, but I'm pretty sure that I've seen formal communication from some of these manufacturers about how they're phasing these systems out. So it's going to be expensive to, in I believe FM200 specifically, maintain these systems because the agent is not going to be made in the same capacity anymore. So it's likely going to be more expensive. So um, but yeah, but I wanted to ask you about, so what kind of spaces or occupancies are you seeing these kind of systems implemented in? I'm sure there's a wide variety, but what occupancy would ping in your mind as being a good fit for these systems?
Well, the product is generally listed for Class A, Class B, Class C fires. That's what NFPA 2010 allows for the technology. Anything outside of that would need to be tested to the satisfaction of the authority having jurisdiction. But Class A, B, C, that gives us a lot of room, um, to move. The product, I see it used in a lot of applications. I think perhaps some of the best applications would be things like equipment rooms, electrical rooms, battery rooms, transformer rooms, things like that. I've seen it used in remote locations where maybe they didn't have sufficient water, to put in some type of a water-based system. I see a lot of applications with alternative energy, battery energy storage systems, and solar and wind, things like that. Some people, and it has been done often, they will use it in server room applications. I usually would suggest when that comes up that perhaps aerosol would not be the first choice because it is an aerosol and there is a cleanup that's involved afterward. Now, if you have a fire, you're going to have to clean up anyway, I suppose. Um, you know, but there are clean agents. There's the fluorinated ketones, inert gases, and things like that. Perhaps that might be a better first choice. But I have seen occasions. One that comes to my mind was a server room for a city, and they were going to put in a clean agent system, and the company came out and they did the door fan test, room integrity test, and the room failed horribly. And they did some investigation in the room to see where it was leaky, put together a proposal to seal up the room so that they could install the clean agent system. And the quote to seal the room came back at like $100,000. And they said, well, we don't have $100,000 for this whole system, allotted. And in that case, they were considering going to an aerosol system, because one of the things about the condensed aerosol system, because it's not a pressurized gas, there is no requirement in the 2010 standard to do a door fan test. We need to have a room that's reasonably closed up. We can't have open doors or windows or things like that. But because the aerosol is not highly pressurized, it's not going to try to seek out every little nook and cranny and escape. There's usually no trouble maintaining concentration for the hold time. And so that's one advantage of the system. And in that particular application, they were talking about moving to an aerosol system because they also had sprinklers in the room. And if the sprinklers go off on their servers, obviously that's probably not going to be a good thing at all. The aerosol, they're going to have to clean the little light residue there. But if they follow certain steps, they should be able to do that and continue to use their equipment. So there are a lot of different things that come across. We protect equipment like CNC machines, different things like that. So there are a lot of opportunities, a lot of things that come along. And I always try to tell people in the training that condensed aerosol is like a tool to add to your tool belt, right? I think it's safe to say that there is no one single fire suppression technology that is effective for 100% of the applications 100% of the time, right? Each one has certain strengths, and each one has certain characteristics that perhaps are not strengths. And so the challenge for the fire protection professional is to identify which solution is going to be best for my customer. In this case, it might be system type A. In this system, it's completely different. This needs to be something different, maybe condensed aerosol or something like that. So it can be used in all sorts of different applications, but I always try to urge people to consider the application, consider the needs of the customer, and consider what is going to be the best solution for that particular application. If we do that, we're going to have plenty of opportunity. But more importantly, I think we're going to give the customer the best solution for them that's going to make them happy.
Yeah, that's a great point. That's a great point. Yeah, it's all about being appraised of the different solutions and applications of these technologies, and what fits and what doesn't fit. So,
Mm-hmm.
um, very interesting to hear about some of the pros and cons of aerosol fire suppression.
Yeah.
But yeah, since you touched on a bit of the location and design requirements, what other kind of, um, programmatic or design and specification requirements should professionals be thinking about when they're looking at applying one of these systems? Like, are there, like, how much room should they intend to have floor space wise or wall mounted, or for these generators? And I know you spoke to the releasing systems and the panels involved with that. But yeah, can you give a high level overview of what kind of other design considerations you would offer?
I will try. The design for the aerosol system, or the calculation for how much of that aerosol forming compound is needed, is basically the volume of the space that we're protecting multiplied by the design application density for the particular product you're using. There are a handful of condensed aerosol manufacturers, and each product is a little different, in its makeup. They're fundamentally the same, but there will be little differences perhaps in the makeup of the compound itself. And so to design that part of it really is pretty straightforward. I tell people I could do it on my phone, probably. We need to know the volume of the space. Okay, so if you've got a room or a space that's 200 cubic meters or 1,000 cubic meters or whatever it is, you just multiply that by the design application density for that product. Now, the design application density will come from the product manufacturer. And a little bit about that. When UL does their testing of condensed aerosol, they are testing the product to identify the quantity of solid compound that will extinguish their test fires 100% of the time. All right. So maybe there's a aerosol manufacturer over here, and they do their tests, and UL says 100 grams per cubic meter. And that is called the extinguishing application density. That is the amount that UL has confirmed will extinguish 100% of the fires every time, the extinguishing application density. Now, when we do our designs, we use the design application density, which according to Nfpa 2010 is going to be 30% extra. So if my extinguishing application density is 100 grams per cubic meter, my design application density is going to be 30% more, 130 grams per cubic meter. And that's what we're going to use, 130 grams times the volume of the room in cubic meters. That's how much aerosol I need. Now, the aerosol generators come in different sizes. They have different amounts of the solid compound. So then what you have to do is say, okay, I need 5,000 grams of solid compound for this room. You would choose the generators that would give you that quantity of aerosol, and then that is what you would use, along with the control panel, some type of detection. Obviously, there's notification involved. Notification for any fire alarm. There's a pre-discharge notification that the system has discharged. Generally, there's going to be a manual release, at least one manual release pull station, possibly an abort switch. The idea or the desire, really the design of the system, is to give people enough warning so that they can leave the room. That way, when the system discharges, the doors will be closed. No one has to go out or anything like that. And so that's it. There are other considerations. Um, Maybe we will consider that as we move on here. But fundamentally, that is my high level overview, I guess. The design is pretty straightforward, really.
Oh yeah, it sounds very similar to clean agent design in as far as the design concentration and the volumetric, capacity of the room and whatnot.
Mm-hmm.
So
Yeah,
that sounds very interesting. I appreciate you going into the explicit details of calculation. I
sure.
know.
There is some things that are required in the clean agent systems that are not required for aerosol. So in a clean agent system, you've got to do flow calculations because you've got piping, right, and certain lengths of piping and nozzle sizes and things like that. You've got to make sure it's going to be able to discharge all within 10 seconds and the flow is right. And if you've got multiple nozzles, that the balance is right. Condensed aerosol doesn't have any of that. There's no pipe. There are no pressurized cylinders. The generators themselves contain and discharge the aerosol from them. So again, from that standpoint, it is a more basic type of design, a simpler system to put together.
Interesting. And so when these systems release, is it like some sort of charge that sets off and disperses these
Mm-hmm.
into the air? Is like a little uh, a charge in this cylinder. I'm taking a look at some
Yeah,
now.
that's it. The fact that they're activated electrically, what really is going to happen here is that solid compound is going to convert to to an aerosol, and it uses a pyrotechnic based chemistry to do that. So the electrical connection to the generator, when 24 volts or whatever the activation voltage is applied, there's a little heating element in there, very much like an incandescent lamp electrically. When you apply that voltage, that thing heats up super fast. And when it heats up, it is able to heat that mass of solid compound, which starts that exothermic reaction from the solid into the aerosol. And the aerosol just sort of expands and comes out of the generator. It looks a bit like a cloud when it comes out, actually. And so that's just the billions of particles, I guess, that are there.
Well, yeah, I appreciate that explanation again on the actuation method. But so I wanted to get your insight on some professional development topics since it seems like you have such a passion for fire and life safety and you found me somehow in this niche little podcast. So I'd love to hear about what other kind of resources you like to use to keep appraised of the fire and life safety industry.
Obviously, I'm listening to you on my phone. There's my technology. And, I listen to the Fire Science Show too. It's very good. I use every webinar I can find: NFPA, UL, SFPE, AFAA. I think I'm signed up for all of them. And so any webinar I can get on, as long as it fits into my schedule, I will attend those. I recently purchased the SFPE handbook. I'm trying to read that in my spare time. I have to tell you that's a little difficult. Yes.
That's dense reading there.
Yes, but I'm skipping around. I'm skipping around a little bit and trying to find the parts that I can understand, which so far is the title page, and everything past page one is way above my head. But I figured, and that's one of the things I like about your show, Gus. I've got to tell you, I listen to your podcast and I start thinking, there's all these people out here that have all this knowledge and experience in these different aspects of the industry, and
Yeah.
it makes me think, I there's so much to learn. I need to try to learn something. I think I bought the SFPE handbook in response to listening to you, actually.
Wow.
Because I thought there's so much to learn. I've got to try to apply myself. I've got to try to grow. It's easy to get stagnant and just do the things that you do. I've been here at Hochiki a long time. I kind of know what everything is about, more or less, and I can go through my day and do a lot of things. But what am I doing to grow professionally? I'm going to buy the SFP handbook. I bought a used one from a library, so it wasn't super expensive.
Thank goodness. Thank goodness. I was going to say, I feel really bad for throwing you into a handbook that is so dense with calculations.
No,
It's
it
like
wasn't your
talking
fault.
about how to determine heat flux of a
Right.
radiant pool fire, like 40 meters away. And poor you're like, he said this was a good resource. I feel like I'm being abused trying to read this thing.
No. You inspired me, and I'm happy to have it. And like I say, I didn't expect that to understand it all, but I did think I would understand a little more than I do. But the point is I've got it, and I've got the internet. There's tons of resources out there, and so if I see something that I think is interesting to me, I can take some time. I can look it up, and maybe somebody
Yeah.
can simplify it down to like second grade level for me. And I'll go, yeah, just like fire. When I was researching fire, how does fire burn? I don't know.
Yeah.
I turn on the stove and the fire comes out. That's it.
Yeah.
But there's a lot more to it than that. And so I've been thinking about that a lot lately. And like I say, you really have been sort of a catalyst for me. Um, Unknowingly to you, of course, but I'm pretty sure there are other listeners out here who would say the same thing. Your
Oh, man.
show makes us think there is more to learn, and there's more that we can do. And so I want to thank you because it's been great for me.
That's very touching, Bill. I sure appreciate that. Um, that's a big deal to me. The more that I've gotten to learn about this show, even starting this show, I don't think I knew. I was just pulling the tiger's tail. I didn't know that, there would be so much that I didn't know about.
Yeah.
I figured that I'd learn about fire sprinkler and fire alarm. I knew about that coming out of school, but I
Mm-hmm.
didn't even, you don't know what you don't know sometimes. And
Right.
just like this conversation we're having now, I could have never told you. Really, it was 3 years ago now when I was thinking about even starting this podcast where it would lead me. So
Mm-hmm.
I
Yeah.
appreciate that. That means a lot. I've learned a lot on my way as well. So that's
Yeah.
awesome.
Well, we're all learning along with you out here, listening to you. So keep it up. Please keep it up.
Well, sounds good. Well, what I don't know if I can top that. That seems like a awesome way to end it. But I would like to plug you for anything that you wanted to talk about more. Anything you want to discuss? Any questions about anything? I answer whatever you want after a glowing compliment like that.
Well,
Not that I'm bribing you.
not a problem. We didn't cover everything, obviously, in this conversation. I mentioned that when the aerosol is converted to solid, it's an exothermic reaction. So when the aerosol comes out of the generators, it's very warm, can actually be even hot if you're nearby it.
Wow.
So there are minimum safe distances that have to be considered. Obviously, because the aerosol is made up of all these tiny particles, there's going to be some impact on visibility. And there are ways to try to address that. You had a podcast with Zachary Green about photoluminescent
Mm-hmm.
technology, right?
Yep.
Photoluminescent exit marking systems can be used. Obviously, training for the people working in these protected spaces. so that if for some reason the system does discharge and everyone couldn't get out, they need to be able to find their way out. And there are ways to help, make that easier for the people. Again, we have the pre-discharge warning, so people will leave, but anything can happen. And another
Yeah.
thing too is we have these very tiny particles, and because they're so small, they are respirable, right? And so if you're in a room when it discharges, you may possibly breathe in some of these particles. They might get into your eyes and sting them a little bit. The discharge is not toxic, but at the same time, our goal, the objective, is to have everyone out of the room prior to discharge. We don't want them to open the door and, have any impact on the hold time and things
Gotcha.
like that. So, there's always more. And perhaps in the show notes, you can put my email address. Certainly, if you want to put our company, web address or whatever information you want. If anyone has any questions or interest in discussing this further, I would be very happy to do it.
Definitely. Definitely. We'll drop some information down in the show notes for those who want to learn more about you or about aerosol fire suppression. And yeah, it's been so great, Bill. You were talking about didn't know if you're going to be able to produce a good podcast, and you produced a Hall of Famer. So I don't know what you were so worried about before the show got started, but yeah, I
Hall of
really
Famer.
enjoyed it.
I don't know about that, but I appreciate it. It's been a real pleasure, and I'm really happy that you reached out to me. And who knows, maybe someday in the future I can figure out something else, and we can talk about. Maybe when I get the SFPA handbook, SFPE. Look, I can't even say it. SFPE handbook. When I get it memorized or something, I'll come back on and we'll talk about those pool fires and stuff.
Man, that's a pretty high goal. I'd let you come on before that for sure on the show about before that, but that
All right.
sounds
Well, it's a
good.
deal. It's a deal, Gus. Appreciate everything you do. Please keep it up.
Will do. All right. Thanks, Bill.
Take care.
Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.